All right. Hi, everyone. We will be starting the webinar in like about a minute. We're just letting people trickle in here. Nice background, Towster.
Yeah, it's looking good.
Yeah, it's a little wild, but it's okay. Um, all right, so I think we should get started. We have a good amount to cover today. Hi everyone. My name is Pearl. I help with marketing at QNect, and welcome to our 2024 product updates. This is just gonna cover some of the top things that we have done with the QuickQnect software over the past year. So we have Michael Gustafson, who will be primarily the primary presenter throughout this presentation. He's the VP of Strategy and Business Development here at QNect. And then we have Jeff Hauster, who is the CEO of QNect and runs all of the technology, the technological team, coding team, all of that stuff behind the scenes here. So, all right, Michael, take it away.
All right, thanks. Thanks a lot, Pearl. Yeah, so thank you everybody for joining this session here today. It's been, I think, a year ago that we presented on our major product updates for QuickConnect with some smaller webinars in between. We're excited to share you the year's progress and efforts. Thanks to many of you customers giving us feedback. And then we wanted to end with our resources, and then we have some other webinars that are focused on a new direction, different direction, expanded direction we're going with Revit, and I want to talk about that at the end. So just a refresher on, a company where at QNect, continue to, grow and expand our products and services, but remembering where we started, right? And that's with QuickConnect, right? QuickConnect was started over 10 years ago, focused on, steel fabricators, the detailers, the engineers working with fabrication companies. And we continue to invest in QuickConnect, and that's what we're going to be talking about today. We also, though, released this past year a new integration in Revit, and we'll just touch on that briefly at the end from a roadmap perspective. And then, of course, we offer our early connected modeling services, which really leverages our technology to help improve the efficiency of the steel delivery process. So, and as a company, their technologies, I wanted to give you first this high level overview of how our QuickConnect kind of fits into our bigger landscape. Underpinning of all of our technology is QNect on AWS cloud services, right? This is where we built up all our, optimization technologies, connection design, the detailing and fabrication data that drives the modeling process in Tekla structures. That's where we started with QuickConnect. What you see above there is the integration with Revit, where parts of that same technology is now starting to be integrated into Tekla, really primarily the early issue detection, checking for issues before doing the actual calculations and modeling and review. So wanted to set that context. So when you see the developments we're doing today, they actually are help, of course, Tekla users, but they actually help Revit users at the same time. A year ago, we talked about a top 10 list of progress. That was for the 2023 progress. If you don't remember or missed that session, we have that webinar up on our new video library for you to check out the progress. So I think it's always good to look at where we've been coming from, holistically when you get these product updates. And one big theme that we've been focusing on before we dive into the details of 2024 is balancing between standardization and customization. This is something we've heard from customers over the years. I think when QuickConnect started off first for Tekla users, we had a lot of, or at least there was a lot of perceptions and probably some reality around like a lot of customization, but maybe not as much power to do standardization. And you can see by the elements here in blue are what we've been improving actually over the last year to allow this broader throttling of doing very standardized this standardization means setting up your standard libraries, lots of repetition, a lot of approaches that might not be they might be efficient for you for modeling, but maybe there's a bit more material used in that approach, but that's the way that companies have been working for years, right? At QNect, our philosophy is to have this nice balance between both so that you can throttle and find greater efficiencies, per project, per fabricator, per, owner's needs around reducing carbon. All these different capabilities here, these bullets are different ways that we're going to be doing that. So today you'll be hearing about standard part tables or our mandated connections, estimating parts, new column optimization of doublers and stiffeners, and all that and those capabilities, how that helps framing and connections being optimized more holistically. So, and then on that middle one here, like connection groups, this is really a very fundamental aspect I wanted to just double click on is the way that we're classifying connection groups, right? And this impacts how many connection types or groups you have, is we're looking at two different levels of classification, both the framing condition, the types, and the framing format. That means related to the forces, and then also looking at the secondary members of connection data. We look back at previous connections. So if the forces are the same, or if the forces follow within that envelope of that connection, all the geometry is the same, it'll use that same group. So when we first started many years ago, there was probably less of that grouping. Now we've been making it where there's more grouping, and that means there's like one calculation for like a bunch of different groups. So I encourage you, if you want more data on this, we can share this with you, but we think that, this is really key for you to be able to throttle between and make sure that you are getting a balance between repetition and customization. So looking ahead then, or looking back actually for the last year, there's really three buckets of investment. So I'm going to go through each of these kind of three categories, but this is the high level overview. We're prioritizing, more like scope of connections, right? Our aspirations is, ultimately to get 100%, right? That's obviously very hard to achieve, but the more we can automate, the more we can free up time for teams to focus on the problem solving, the customer facing aspects that are so critical to your business. So we'll be talking about the different connection types we've been investing in. Then secondly, flexibility, being able to use our tools, but get to the last mile. I think this has been a very important area for us to invest in. And I hope that you as customers can give us more feedback in this area. Getting that last mile, the automation can get you so far, but then last minute changes or being able to customize that one last connection. How do you do that at the UDA level, or being able to accommodate changes and not revising or allowing the revisions to happen? We'll see some updates here that I think are helping support that. And then the third bucket is around engineering, integrating design and engineering. We continue to invest in new types of calculation types or things that are helping the engineers and the teams better view and analyze their data. So on connection types, I wanted to say first is our historical data, we did a while back, looked at all the different connection types that customers are running, and we saw that HSS filler beams and column splices were like kind of near the top. And so that means that connections that didn't connect for various reasons, and that could be, we didn't support these connection types, right? We did support, some HSS framing conditions, but not that many. So for column splices, we've now in the last year implemented gravity column splices. So when I say gravity, these are really what's specified in table 14.3 in the AISE manual. And this is for typical column splices, really, no moment forces, they're not slanted, they're vertical, columns. And we allow, you can see the details here, bolted flange plate, column splice connections. So not welded or bolted to web yet, but this is like our first phase of this, and with lifting poles and all those details. So we're excited to have a first version of column splices here for you all to be implementing for your gravity columns, and we'll be posting this video, of course, um, on our web, our video library, so you'll be able to go through this and see this video. But here's like in the interface, you can see where would you like to use gravity column splices. This is within the minimum job requirements. Once you activate that to yes in the minimum design requirements, now you'll have it show up in the left under under advanced, right? You'll have the bolting splicing tables that show up here. So then in here, you can go in and start specifying your plate materials, your filler material grades, building out the framing combinations, right? The lower column, the upper column, and then all the various parameters that go with that. I'll just kind of fast forward through here. So you'll be able to then, when we bring that in, once you fill out those parameters and those combinations, it will come in and apply that particular connection. We're very prescriptive with this, right? Because we're following that table J 14.3. We're not doing any calculations per se, because it's all kind of prescriptive based on the code. So we'll look forward to your feedback on this. So then the second implementation I wanted to talk to you about is on the HSS we call filler beams to wide flange support elements, both columns and beams. So here you can see three new types of combinations of HSS beams. So this is secondary beams where they frame in with end plates, shear end plates into the columns, both flange and web, and to beams. Remember, we already have W-shaped beams framing into HSS beams. That already exists. So this is kind of adding to that existing combination. So we're excited about this because this, as you saw previously, this is like a common no connect reason that came up for, from users needing to connect, whether it's girts or elevator openings. And, there's a lot of those secondary framing into the primary framing that users are wanting to connect. So yeah, so I say it's in beta. We're basically going through the last round of testing here. It will by end of the year be available. Just keep an eye out in our release notes for that update. So then number 3 with connection types is our single angle vertical bracing. So we've started, you remember a couple of years ago, the HSS vertical bracing. Now we release single angle vertical bracing. We're working on wide flange bracing next, but this is our single angle vertical bracing for both column flange and column web. I think a year ago in a webinar, we had like the first release of the column flange. We've been enhancing the vertical bracing with column web capabilities. So we have a video online for you to take a look at. And we know, all these different bracing combinations are, dependent upon, well, if you're the fabricator, of course, it's dictated by the EOR, but a lot of this, it's force driven, right? So some projects, maybe more industrial projects, we see the single angle vertical bracing. HSS is used more in building structures. We'll talk later on about the prioritization, the direction of where we're going to keep expanding on the vertical bracing. Connection types for Canada, where we have customers doing Canadian code designs. Last year we expanded on the CISC, to have all the clip angles or the double angles, the shear plates. So now we have added end plates, and this is actually more quite common connection in Canada. So for Canadian customers, this is going to be helping them with their traditional shear design. And and Jeff Hauster, just to verify, is that shear plus axial, or is that how much variation do we have on the shear or shear plus axial with the end plates? Putting you on the spot here.
No, it's shear only for end plates today.
Okay. All right. That's good to know. All right, and then moment connections, we keep to enhance things. Here we added a limitation parameter around the length of the overall embed plate because this is due to shipping restrictions, not to exceed 9 foot lengths. So if you have a column like this, you have the column, a deep column, or a heavy 14, and then you have, long flange plates extending out. You want to keep that less than 9 feet lengths for shipping purposes. So we're not over, designing beyond those capabilities. All right, so that's on connection types, that first bucket of investment we've been doing. The second investment is around the flexibility to be able to go that last mile, and modeling and detailing capabilities are key here. I think the sloping, this first one here, I heard a lot of this feedback from customers over the last 2 years that I'm happy that we've implemented. This is to do both increasing our slope tolerance. So the slope tolerance used to be less, I think it was 2.5 degrees or some, but it's now at 5% slope, right? And that's, we're not decoupling the forces at all. That's still using the vertical resultant forces, but that's okay according to that's the condition that we're, the assumption we're making. And that's, you know, from the customers we talk to, acceptable. So we're going up to 5% slope. And then the skews already go 5% off the orthogonal. And then we do skew and slopes together then too, right? Because you have conditions where you have both with, say roof situations or, floors that are sloping and you need skewing as well. Then with bolt clearances, more controls on being able to control the clearances on extensions of like bolts, doubler welding clearances. This is for customer feedback on, having enough room to get in there to actually weld like beam doublers onto or column doublers. And then just more flexibility around beam flange corner cuts. Uh, and also this bottom one here showing the picture on the right is allowing the girders to be rotated with the filler beam slope, right? Because those beams are coming into that girder relative to each other at a right angle. So, and as long as they're kind of relative to each other, perpendicular, framed up orthogonal, then that's okay. So we're supporting that, which before we didn't. Then from a managing revisions, this was really a key feature that customers asked for is they wanted a better way to more flexibility on how to control changes or embrace changes, model changes, and how they impact the QNect calculations or triggering the modeling. So now we allow with this listener feature, and this is under the settings, is that you can go into having these changes with the listener is turned off. That means that the listener will not be looking for changes in the model, right? So if you have it off, you can wait to turn it on later and basically run all the changes at once at a later time. This could be for, maybe there's a bunch of changes happening. You don't want those changes yet to propagate in the model from a QNect standpoint. This gives flexibility for who on the team should actually update the connections, right? So this was, I think, implemented in the beginning of last year, and I think we've heard strong feedback on this. So then in terms of more flexibility, the next few slides is going to be talking about enhancements to our standard parts and this new estimated parts. And I wanted to first frame this up in terms of how we are now allowing teams to model and design their connections with a hierarchy and greater flexibility, right? I think, years ago, we actually did not have standard parts here. We started where we kind of just designed all connections based on the preferences. Then we implemented a couple of years ago some standard parts where you can start setting up, for every, say for a clip angle or shear tab, explicitly call out all the details that you want, the bolts, the plates, the welds, all that information for different framing connections. Think of it as like an auto connect, on steroids that you have within Tekla. Okay, that standard parts is the first step that we look at when we're running our, running the design and the detailing. And so, but then the engineering and detailing then, which has always been there, that's looked at secondarily. So for any connections that don't connect or can't be met by the limit states, it'll go through and we'll go through the runs through our detail, all the other preferences that we have. Um, and then, and then the last step is the estimated parts. Now, you'll see that within our software, we have now at the beginning of the job standards, three different modes, right, that you pick at the beginning. Do you want the full detailing and design mode, which is the traditional? That's what users have always used, but you'll see these two new modes then of detailing only and estimating only. And that's for then users to be able to use, so like estimating where you want to, you know, you want to use like a third hierarchy of estimated parts that we are not, it's basically ignoring certain no connects, right? Or reasons why the connections can't be designed, but still putting a connection in there so that you can properly estimate. You won't want to use that in like the actual detailing because those are not designed right at that point, but this estimating allows for more accurate quantity takeoffs. So any comments you want to make, Jeff, about that hierarchy or anything before we go into the mandated discussion?
Just that it's the order of operation that we follow. So if you guys are specifying standard parts that the EOR gave you and you want to follow it, you can pop those in and we do whatever you say, but we check to see that it hits all the limit states. Make sure that the connection is perfectly designed. And in standard parts, you can also just specify certain criteria. You can say, you know, what size weld, what size bolt that you want, but not give us any more detail. And we'll actually design it using just the criteria you gave us on standard parts. After, or if we don't find anything that works in the standard parts section, then we'll do our normal iteration process that we do today, that we've done for a long time. And then if we were unable to design it so that it meets all the detailing criteria, all the erection criteria, and all the limit states, it will then look on the estimated parts to see if maybe you just wanted to, you're using this as an estimating process and you wanted to be able to show your full model. And we're able to get like another 10% or so of the successful connections put in there. We're not checking a lot of things and detailing if there's any clash or anything like that, but it allows you to put in an estimate where you can actually count all the steel and bolts.
Yeah. Yeah. So you can imagine for estimating, that's like, where speed, it's all about speed, but yes, using your even more conservative estimates the way that you do now. You haven't yet done full connection design, but that's okay at that point. So, and yeah, and we think this over here on the left, this flexibility of one and two, where you can use your standard parts as far as you go, and then we'll come in back behind there with our engineering and detailing to validate everything. So that's a nice combination back to that big picture about standardization versus optimization. I think this 1-2 combination is a great way to balance that, and you have flexibility of how to push and pull on those two approaches. This is quite new to QNect. I mean, I think a lot of users you just haven't really explored, or you saw the standard part details show up, but I hope this discussion here helps you understand how to fit it in together to your workflow, because it's going to really give you a much more flexibility in how you work. So just on the standard parts, then what we've been expanding there is we added, yeah, like OSHA bolt row overrides. You can see that over on the right, just adding more capabilities. This enforced connection, yes, no, this is the customers asking for this at the connection scenario. So this is for a given standard part, say like a shear tab framing in, W8s to, W10s or whatever that combination will be. You can flag it to stop. So if it's set to yes, to enforce, that means enforce the mandated connection. That's it. Don't do any more. Don't try to find a solution. If the force, for example, you increase the force from 30 kips to 80 kips, it doesn't work, it'll flag a red cone. That's down here on the bottom. But if you say, no, I want you to keep going past that. I want you to go past my mandate and go to that step 2 on the previous slide, which was the engineering and detailing there. Then it'll keep going. So that NC, so when that setting is set, it will keep going for that specific framing condition and try to find a solution based on all the preferences that you've set up within QuickQnect. So it'll obviously increase the number of rows of bolts to increase to reach that 80 kip capacity or whatever it is. Yeah, so to activate this setting, again, this is just a note about you set it up within your minimum job requirements, and then you need to fill out the settings. So, and then this is a quick video. I probably won't play through the whole thing. Let me just fast forward. But here, just showing you where this shows up in the interface so you can see the mandated settings. We, by the way, redid the menu on the left here so that it's more logical, like the names and kind of grouped things into the same groups like bolts and welds, the way that would make more sense. So, but yeah, all our mandated settings are here. You can just see examples of the picking the different framing conditions. It can be for specific members or families, right? Like W16s, the W24 shown here. Let me just scroll over and then, yeah, oh yeah, and then by the way, to show you here, you can, with any of these tables that we have, you can copy paste, from Excel and or from row to row, right? To kind of work through that. So this video just goes through and shows that image I was showing on the left graphically before. So this, where we put in the connection, where the setting, this is like for a given, say, I think 30 kip loads. This is the first connection. So, and then it's got, yeah, just four bolts in it. So then if I just fast forward, I'm going to increase the force to let's see, we're going from 40 kips to 90 kips. Okay, so 40 kips to 90 kips. And then we run it, and here the setting is set to, I think this is to tell it to continue to optimize. So this is where the enforce is no. So so the enforce, we're not enforcing it. So it'll go from mandated, and then if it doesn't work with mandated, it goes to that step 2, which is our detailing and engineering preferences, which say, yes, go through the looking for multiple, rows of bolts or whatever strategies to design this connection. That's what we've gone ahead and done. All right, so then you can say, okay, I want to actually deactivate that. And this could be like in the early stage of a project. We were talking to a customer who said, I want to run my mandated at the beginning first, early, and just see what doesn't work based on my company's standards, right? So whether that's an engineer, tables, or the fabricator has certain standards, I just want to run in everything and let me know what works and doesn't work, right? Green cones, red cones. Okay, but then when you find the red cones, you can be like, okay, well now let QuickQnect go through its optimization and go through its other preferences to then make those work. But at least, and these connections are all met, there's data on them, right? So you can filter them in Tekla, you can isolate them, you can view them, and flag them to kind of quantify them based on what's mandated versus what's really delegated, I guess you could say. Yep. So that's a workflow quickly on the mandated and how to put that into place. Then on the estimating, these are really the steps to set up, as we talked about on those, if I go back to that previous slide here, remember with estimating, it's going through standard parts, the engineering and detailing, it'll try to do that, and then third, the estimated parts. So when I go back here, you still have to set up your engineering and detailing preferences because that was the step 1 that it was trying to do. And then of course the step 3 is the estimated parts table. You have a new table where you can add those connections that, yeah, we're not running the calculations on, they're just kind of auto connect. It's the auto connect with no calculations associated with it. And we're calling it, estimated for the connections that failed. So, but that'll let, as Jeff said, get you that extra 10%. Say if you connect the model 85%, if you can get to 95% for estimating, that's a big win. So, and then the last part, our last couple of slides on the flexibility, we invest in usability, customization, aliases, defining what the aliases are for different types of plate material. We're also sending notifications for session runs. Excuse me. So before we didn't have the job summary and the Connect report together, but now they're all in one place. And then usability preferences, or the usability of the preferences, I mentioned this reorganization of the tree at the left. That is, helpful for, just new users too, to get familiar to how to use our software. Okay, so then we're moving to the third bucket of investments, and that's around engineering. And we implemented some fatigue loading. This is based on a customer, a project where this was really critical for a building project. So, but it actually uses the bridge, the LRFD, the AASHTO 2020 building codes. And we're doing this for shear plates, shear forces only, and looking at very specific criteria per these codes. But what's interesting here, this is, doing, of course, the normal limit state checks, but these additional fatigue checks for these gravity connections. So if you have any projects coming up that, it could be structures going over a highway interpass, or, something where you have, traffic that's driving, that has to be designed with steel underneath a mixed use project. I mean, we have this capability that may, meet your requirements. Then we also have helped, made updates to our calculations for moment connections. We do the moment connections for built up box columns. So if the moment connections are connected to a box column, which is a built up parametric shape, we're able to do that moment connection calculations just like if it was a wide flange beam. We also have implemented the strength reduction for fillers with slip critical bolts, and that's per the AISC 15. And then this is one of my, I guess, favorite in terms of engineering, because I know as an engineer, you try to design your framing efficiently, right? But there's always these inefficiencies. And so when I worked at AISC as a regional engineer, this is like an area we were trying to help train up engineers on, is how do you balance, adding stiffeners and doubler plates for moment connections versus upsizing columns, right? And what's that balance, right? So, well, now in QuickQnect, we run this optimization for each of the joints where there's moment connections, and we actually give you proposed options for the column profiles. So, and this is based on, equivalent, section modulus depths, right? We're not doing some finite element or anything in the background here, but we're giving you equivalent column, weights and capacity options here, both for 50 KSI and 65. We know there's a trend towards 65 for columns for, sustainability purposes. It helps, reduce costs on projects. So we're giving you the sizes for you to eliminate the stiffeners or doublers or both, right? And so this is what I'm showing here as a workflow is, kind of at the one level. You, of course, can run reports. Like if you have a bunch of column doublers in the model, we have on our website, of course, the QuickQnect reports, doubler reports, and you can run a list for the entire model. We think this is interesting, right, for future, because this same capability that's in Tekla, of course, will come into Revit as well, which is going to be super valuable for Revit users. And then also visualizing engineering data. We've been, sharing, users were always able to run their own analytic reports, but it was very kind of text heavy, like with the reports that we have, to be able to compare connection type combinations with bolt pairings and looking at number of bolts saved. Well, now we're able to visualize that, like bolts saved, cost. If you have the costing data, you can have that data for, in the future, we'll be looking at cost and carbon together using the same type of framework, but starting to build these reports on our visualization charts on our website, I think will help you make faster decisions on, what connection strategies to use and bolt pairing strategies. So if we look now, that's kind of a summary. In 2024, we think like we've made some great headway in addressing, scope, flexibility, and engineering. Looking forward, these, some of these are just ideas at this point, no commitments, but we are working on wide flange vertical bracing. That is actually happening now. We are exploring, what other vertical bracing combinations. If any of you have a strong opinion or you want to put them in the chat here of that, I mean, we've been thinking about, chevron bracing or bracing at the base plate locations with vertical, of the existing ones we have, or horizontal bracing. We think these are all important. It's about priorities and hearing from customers what's most important. Second, on the revision management, I think the more we can do with revision management to let you get that last mile, that's very important. Usability, we're looking at like a connection, 3D visualization of connections, not kind of before you get into Tekla. And this would be before you even getting into Revit too, is like a way to visualize the connections, and that could help you with this making your decisions. And then engineering wise, just continue to look at, we're working on comparing cost and carbon data because embodied carbon reduction is becoming more important. Moment connections with, shear plus axial, just exploring how important that is. More QC checks for EORs, things that help engineers make their models more constructible. So looking ahead, that's a recap on really where we're going with QuickQnect. I did want to say a few words about what we're doing with Revit and how that compares to what we're doing in Tekla. In Tekla, we're doing all these things, and we keep improving more connection types and offering more revision management, and that enhances the design and modeling. So with Revit today, we have really the early issue detection and connection design calculations are actually running in the background. What we're looking in the future is having more, the optimization capabilities from a more kind of lower LOD level, but allowing engineers to make better decisions around their framing and the impact of connection design on the framing and being able to make visualization decisions on that. So that's the direction we're going. And what we have today with QNect, focused on issue detection it's really two things. One is finding reasons why connections or framing can't be connected, why the connection designs or detailing don't work. And then secondly, if they do work, identifying where the complex reinforcements are. So per the code of standard practice, engineers need to be documenting those complex joints on their drawings. And so this tool is helping them do that by identifying those locations. And so in the future with Revit, we see, these things we're doing with QuickQnect actually help the Revit workflow, HSS, more HSS combinations, connecting to embeds. I mentioned moment plus axial, and usability of the tool, how to visualize the no connects in an easier way. And drawing maps like we have in our QuickQnect today, you can create drawing maps, which is great for Tekla users. Well, that same ability to visualize, connection codes or locations of doublers on plan drawings, that's all very possible, with Revit because all the data already exists, right? We just need to annotate it on a different drawing platform. So that's where we're going next. So just overall with, QuickQnect, we've revised our website. If you haven't been there for a while, you'll see a refreshed look. We have kind of refreshed our training videos, have the most relevant ones up there, added some new ones. The release notes are in a new location. If you have any questions about what we've been talking about or want to give us feedback on our roadmap, we most definitely look forward to your feedback. You can contact Jeff or I or get connected to us through the support email shown. So with that, I would like to open it up for any questions. So if Pearl, you see any interesting questions or we want to add any more detail, we can do that.
Yeah, so let me see. I think chat is open for everyone. And I do not see any questions right now.
All right, well, that's fine. And so, Jeff, did you have any additional thoughts you wanted to say about what I shared there too, like at the end, the philosophy around where we're going next, or?
Well, the bottom line is I want to know what you guys want. So if there's something that bothers you about Qnect, let us know. We'll fix it. If there's something that you want a new connection type, we'll do it. If there's some usability that you think that would make it easier to use, we'll let it rip. Just let us know what you want, and we'll pop it in.
Yeah, that's right. I mean, we know there's a lot that goes into this because what's different, I think, what QuickQnect is doing versus other tools that do parts of what we do is we're not just doing the connection design, or we're thinking about fabrication and detailing and constructability. So, but that's great, right? Because at the end of the day, that's going to create more accuracy. And the more we keep increasing the scope here and the flexibility, it's just going to, yeah, give you that much more time to focus on the real problem solving, the customer facing interactions, the things that help you differentiate your business. And yeah, whatever we can, the areas you think we should be investing in, or maybe there's other areas you think that would, hey, if QuickQnect you did this, that would really help our day-to-day work, please let us know. All right. So yeah, if there isn't any more questions, this is a 45 minutes, I think is a good stopping point. And yeah, we can end it there. Any questions, Pearl, that showed up? Otherwise, we can close it off.
Not right now. Like you said, if anyone has anything, feel free to contact us. We want to hear from you. And yeah, thanks everyone for joining. I hope that this was valuable and helpful to you, all of you.
All right. Thank you, everybody.
Right, thanks.